So we're going to look at the worksheet for calculating table of values for quadratic graphs. Okay. What I've done on each one of these is I've added the table of values at the top. Okay, what I would suggest you do, I'll watch through the first one, okay, and then have a go at the next, complete your table of values, and then see if you've got it right, and then I'll go on to plot the graphs. So the first one, you can tell in the question itself, all it gives me is my x and y coordinate, as we've done in a previous lesson. Okay, so it tells me that it needs me to plot the graph for the x values between -2 and 3. So hence in the x part of my grid at the top, I've got -2, -1, 0, 1, 2 and 3. So all the coordinates between x coordinates between -2 and 3. Okay. So we're going to write those into the top of our graph at the top here, mirroring the values they want me to calculate for 2 and 3. Okay. First step is I'm going to find x squared, and you will find x squared will be the same on every single row. Okay. 0, 1, 4, 9, 1, 4 cannot be a negative square number. It's always positive. Two negatives times together to make a positive. Okay. If I'm looking at the next row down, there is no x value involved. So really simple, that's my constant value. -1 is going to get written in. Okay. And now I'm going to try and calculate y. And I calculate y, remember, by adding together the x squared and the -1. So x squared minus 1 is going to give me the value for y. Okay, so I'm going to start with, doesn't matter which end I start, let's start with a negative. 4 minus 1 gives me 3, 1 minus 1 gives me 0, 0 minus 1 gives me -1, 1 minus 1 gives me 0, 4 minus 1 gives me 3, and 9 minus 1 gives me 8. And again, you should be able to see there's my line of symmetry, that's my lowest value, and it's going to be going up from each side. Okay, and that's my middle value. Okay, so I'm just going to calculate now and put the y coordinates into my grid that we've got here. So that's going to be 0, minus 1 they give me, 0 in there, 3 and 8. Okay. Now if you can imagine this as coordinates, I'm going to take from this end, that's my first coordinate. So I've got 3 along the corridor, 8 up the stairs. This is my next coordinate. I've got 2, 3, and so on. I can write the coordinates down. You don't have to write the coordinates down, I'm just doing it so you can see where the coordinates are coming from. X coordinate is always first, and I can now plot them. Okay. If you can plot them directly from the table of values, feel free to. You don't have to write the values down like we have done there in coordinate form. Okay, so looking at the first one, 3, 8, 3, 8. Next one back is 2, 3, 2, 3. You've got about a little square, one of the small squares is about the leeway they give you on an exam. 1, 0 is down there. Okay, so try and be as accurate as you can when you're plotting this. 0, -1, that's my turning point. 1, -1, 0, and 2, 3, -2, 3. Okay, once you've got the points plotted, carefully draw the graph. Okay, so you're going down. Remember, we're turning at the bottom, we don't go to a V, and we don't square it off. Okay, so that would be the points plotted. Try and show you the whole graph. Okay, if you can do it without doing this table of values, okay, then you don't have to draw it, but it does make it easier to see what's happening at each stage. Okay, the next one I will go on to, I will show you how to do it without the table of values, with the substitution method. Okay, but that is question 1 completed. Question 2, we've got the table values at the top. Okay, but what I'm going to do is I'm going to substitute in, and again we're just going to zoom in a little bit on here. Okay, let's ignore the table of values that we've got at the top. Okay. Okay. So ignore my table of values, and I'm just going to write the equation. So y equals x squared plus x. Okay. Now to do the substitution method, all I'm going to do is where there's an x, I'm going to take each of these values in turn. So I'm going to start with 3. My advice is always start with the positive. Okay, because then we're not throwing the negative values in to make us go wrong. Okay, and if you can see where the turning point is, then that will help a lot. So I'm going to start with positive 3. When x equals 3, so I'm going to rub the x's out, and I'm going to substitute them, okay, for the value 3. So when x equals 3, okay, 3 squared is 9, plus 3 is going to give me 12. So all I'm going to do is calculate the value. We know that the next one is 2, so what I'm going to do is I'm just going to put the 2 in there so we can see where that's coming from. Okay, the rest of it stays the same. Okay, so 2 squared is 4, plus 2 gives me 6, and you can see that that is 6 there. The next one they give me, so I don't need to calculate it, I need to know what it is when x is 0. Okay, so again, substitute these out, rub these out. 0 times 0 is 0, plus 0 is going to equal 0. So that's going to be 0 there. The only one I've got left to do is negative 2, and this is why I would always start with the positives. Okay, if I can see where the turning point is, I've got 6 here. Okay, so I can see it's coming down, coming down, coming down, coming down, coming down to 0, levels out, goes back up, 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 up to 6. Okay, so I know this value is going to be 2. My turning point, if you can see, is here in between the two zeros. Okay, and then it's going to go up to 12 this side. Okay, so I can see that from the shape of the graph, from the numbers that are there. But we're going to calculate this one to see that it is going to equal 2. Right, so I'm going to put negative 2 in there. Negative 2, negative 2. So negative 2 times negative 2 squared is going to give me positive 4. Remember, negative 2 times negative 2 equals positive 4. Plus minus 2. Okay? A plus and a minus together gives me a minus. So I end up with the sum 4 minus 2, which equals 2. Okay. But hopefully you will see there is quite a bit. We could go wrong with the negatives there. We could go wrong with the negative there. So my advice is always start on the positive, this end, and work your way to the left, and do the negative numbers last. Okay, so hopefully you can see a pattern by the time you get there. So we know that's 2, we know that's 0, we know that's 12. Now we're going to come to plot it. Okay, so just going to make it a little bit bigger so we can see it. Okay, so I've got 3, 12. So 3, 12. So that. We've got 2, 6. We've got 1, 2. We've got 0, 0. We've got negative 1, 0. Okay. We've got negative 2, 2. And then we've got -3, 6. Okay, so just going to again make this one a little bit bigger so we can see where we've plotted points now. And if I'm going to join these up again, take care with joining them up. Always come from the edge of your graph, try and come through the center of your points. Right, when I get to this point here, remember I can't go straight across. If I go straight across, I'm going to lose a point. Okay, they're going to take a mark off me. It's still got to be a curve, and it's got to come underneath that line and go up like that. Okay, that curve is really, really important. Okay, it doesn't flatten off at the bottom. If we're thinking about that when we did our key points, remember my line of symmetry is going to come halfway between the two lowest values. If I have two lowest values like a median, the halfway point is going to be halfway between those two values. That's my turning point and my line of symmetry. So again, there's my turning point. If I'm looking to see my y-intercept is that point there where it crosses the y-axis. In this case it's 0, 0. And if I wanted to know the 2 points on this graph that are the solutions, I've got one solution just there at -1, 0, and I've got one solution there at 0, 0. They're my two solutions. My y-intercept is 0, 0, and my turning point, a little bit more difficult to see, is that point there. So my turning point or my vertex, if we're thinking about each of these squares, I've got 1, 2, 3, 4, I've got 5 little squares makes 2, so each square is going to be 0.4, and you can see we're about 1 square down. So I'm going to say that my x coordinate is minus 0.5, and my y coordinate is going to be minus 0.4. So that would be what I would put for my turning point if I had to detail that down. Okay. What I'm going to suggest you do now is pause the video, have a go at the remaining graphs, and then we will go through the answers. Okay, so going on to question 3, you can see we've completed the table of values. Okay, on the remaining questions I've done the table of values so you can see where all the workings are. Feel free to correct as you need to, or mark if you've got it all correct. Okay, once I've calculated it, remember they give me these values, so I only have to calculate that. Again, if I can get to the point of seeing where the turning point is, where the vertex is, they've given me the -2. They've given that I'm just needing to find the 4 in that case. So do the positive one first, and then you can see the pattern. Okay, plotting the points, you would end up with a graph that looks like that. I'm just going to make this a little bit smaller. Okay. Okay, so looking at that graph there, we can see we've got the two solutions are at these points here in red where it crosses the x-axis. We've got the y-intercept where again it crosses the y-axis. Remember, this is my y-axis. And then I've got the vertex or the turning point, where is the turning point right at the bottom of the graph. If I want to show a line of symmetry down there, again we could draw that line of symmetry exactly where the turning point is and show the line of symmetry. Okay, for question 4, again table of values is there. We end up with, there's no values to go by on this particular question, so we end up with 4, 1, 0, 1, 4, 9 and 16 are all of my values written in, and then I can plot the coordinates, which gives me -3, 4, -2, 1, -1, 0, 0, 1, 1, 4, 2, 9 and 3 and 16. Again, I've shown on there the points of the 5 key points. We've got the vertex, we've got the solution. There's only one solution for this one. It only just touches the x-axis, so where it touches the x-axis, that is my one solution. Okay, my y-intercept is where it's again crossing the y-axis, and the vertex again is the turning point. If I wanted to draw in a line of symmetry, I would do it through the turning point. Question 5, slightly more difficult on this one. The first one at the top there, you can see hopefully, is 3x squared. Okay, 3 times x squared. So I would need to calculate x squared first, and again that would be, I'll do it over this side, so that would be 41014. That would be my x squared. Then I'm going to multiply that by 3 to give me 3 lots of x squared. So times each of these by 3 times by 3 is going to give me 12, 3, 0, 3, 12. And hopefully you can see where these values now come from. The third line down is a constant. There isn't an x value involved, so it's just +1 on each case, and then I'm just going to total that. Okay, now again, if we can see the turning point, they've actually given me all of the values in this one. I just needed to copy the 4 across and then copy the 13 across. Okay, never just presume that they've given you all the values. Make sure you calculate one, and again calculate the positive side to help. Okay, once you've got that, you can plot the values in, and you would end up with a graph like that. Now with this one, my y-intercept is on there, my vertex is on there, my turning point. If I drew a line of symmetry on there, it's going to be exactly down the y-axis. That's my turning point and my line of symmetry. Okay, but this time it doesn't cut the x-axis at all. Okay, so if you can see, the x-axis goes across there. My graph doesn't reach the x-axis, so therefore it's classified as having no real solutions. Okay, so there's no solutions to this one because it doesn't cut the x-axis. Okay, and the last one, slightly more again slightly difficult in a way, because we've got, notice, a negative x squared. Okay, so my first line is my constant, there's no x value there, so I'm just adding 4 to each line, and then negative x squared. Remember, we've got our x squared value, 9410149. Okay, so they are just my square numbers. So if that's an x squared, if I want negative x squared, then they all become negative. So hopefully you can see again where the negatives here. It isn't that they are negative 1 times negative 1 gives me negative 1. Okay, because it doesn't. X squared will always be, that part will always be positive, but if I then make it a negative in front, it turns them all negative. Okay, so just be careful. That's what makes the graph turn upside down, if it's a negative x squared. Okay, so instead of having a u-shaped graph for an x squared, we're going to have an n-shaped graph, which gives you a negative x squared. So once we've calculated those up, 4 take away 9 gives me negative 5, and so on. I've got to find my two values there. Again, always start with the positive, and it gives you my negative x squared graph, hence draw the graph. Now, you can stop at that point there. You don't need to draw the graph past that point. You won't lose marks for not drawing it past that point. As a rule of thumb, if it was me drawing this in an exam, I would make sure that I extended this graph until it goes to the end of the graph paper. even though they don't give me the point 3. Remember, there's my turning point. I already know what that point is because we've calculated it. This one's going to be -5 when x equals 3. Okay, it's symmetrical. And again, draw my line of symmetry on. There's my line of symmetry. Okay. There's my y-intercept, and my maximum in this case, it's also my vertex. And if I want the solutions on this one, I've got one there and one there. And again, I can just then write the coordinates if I need to. Hopefully that makes sense. Any problems, drop me an email, and hope you got on alright with the worksheet.